Welcome back to Chapter 5. Today we're going to finish Chapter 5. Last time we started with the PMS databases and what type of information do we want to keep and how much resources do we need to have to establish such database, including people, data, hardware, software, and so on and so forth. Today we're going to keep continuing on talking about several types of PMS database and some specifics that deals with organizing such database. So one of the things that we will be talking about under the PMS databases is the database management system. Typically we refer it to DBMS. So the database management system has to provide at least a mechanism for the application programmer to write programs which eventually will manipulate the data and include more data or remove data as needed. So there are different types of database management systems. The first one that we will be talking about is the relational database management system, which is basically that system allows the users to perceive the database as a collection of tables. So those tables, every table is going to handle different type of information. Most commonly, this type of database is used on PCs. One of the softwares that I have seen before was DBase 3 or 4 that used such system. This is here what I'm talking about. You would see this is illustration for this type of relational database, and this figure here shows you the roadway database table. And the very first thing that we typically have in terms of columns is the location reference. Typically we always relocate or locate the first 2 to 3 columns to reserve them for the location reference, especially when we deal with a national database like some of you are dealing with the LTPP database, the long-term payment performance database. This database is huge enough to include all the states, so we have to recognize that some sections will be in Texas, for example, and some in California, and to do so we have to reserve the preliminary columns to tell the users from the very beginning that this section is located at certain state, and that is typically the very first column. Then also you may use the second column or the third column to use it as longitude or latitude or the county or the city within the state. This is very crucial to make a distinction between different payment sections. Also, as you would see here, you have also to include the class of the roadway. Sometimes you have to do that. What's the class of the highway? Is it an arterial, freeway, highway? That also would make a difference. And as you could see here, for example, this one here, it may happen to be arterial, but we may have another row for a data that shows for a freeway or a collector. And then once we start to fill the introductory information, then the next rows would be for the database record. I can have one column for fatigue tracking, I can have the second column for routing, and so on and so forth. The other type of the database management systems is the hierarchical system. Hierarchical system is very similar to more or less like a tree setup. So basically you need to start at the root and follow the specific branches all the way to get to a particular leaf. So it's more or less it's like a main frame. It's more complicated, and we try to avoid it, but it's existing and it's used for so many years, and it's been used in so many states and payment management systems. So underneath either the hierarchical system or the relational database system, we're always gonna deal with application programs. Those programs are very important to use and very important to understand to make our lives as payment management system engineers much easier. Those programs typically, as a good candidate program, they have to ensure integrity and also the validity as well as the security of the data. So if you have a program that have issues, for example, with securing the data or with keeping the integrity of the data, that program might be not a good candidate to select. Also, while you're thinking of selecting a good application program to be used as the payment management system tool, you also have to think of does this program provide standard reports to end users? Yes, you might be the only engineer that understand the outputs, even if it's very not organized and not standardized, but you have to keep in mind that there will be so many other personnel rather than you that will be looking at the output. And one of the big criteria for any application program to be implemented in a payment management system database is its easiness to produce standard reports for end users. The third criteria that you have to think of while you are picking an application program is, does this application program able to analyze data in the database in a consistent and reproducible manner in order to produce standard reports? So as you could see here, it's all about consistency. How can I put the data in and then all the time I'm gonna see very similar look of the report, which is gonna make it much easier to look at the report, pick the numbers and have a quick conclusions. So pretty much those are the three major criteria that you have to keep in mind while you're trying to select an application program to be used for payment management systems. In some cases, while you might be the only one to start a payment management system database, you may think of the simple roadway database. What is the simple road database? Is simply it's a one row of each section of road in the database and one column for each data element which describes that section. So basically you would have one single row that has every single information related to that section. Once you move on from row number 1 to row number 2, that would be another section, and so on and so forth. So this system, it is really collected either using control sections or uniform sections or either candidate project sections as well. This is here an example of what I'm telling you. As you could see here, for every row, the very first row is section number 001. So that section 001, this is the ID. This is how I can understand this is the first section. Then you would see 3 to 4 columns that has inventory information. Inventory information may include geometry, how many lanes, simple traffic information, or maybe the traffic is going to have its own columns, but those are inventory informations. Then we're going to see maybe sometimes it goes from one column all the way to 10 or 15 columns that handle the observed distresses in the field. Sometimes we see one single column for fatigue, summed up all the severity levels and extent levels. And in other database, we can see 6 or 9 columns just to indicate the fatigue data. Every column would have its own extent or its own severity, whether this fatigue is sealed or non-sealed. You could see that amount of extension and extended amount of data. Same thing for the distress of rutting. You can see 2 columns of rutting, one for the right wheel path, one for the left wheel path, and then an average column, or you may just see an average column. When it comes to traffic, this is also, you may see one single column related to the average annual daily traffic, or you may see another column for the truck percentage, a further column for peak hour factor, and so on and so forth. Then you may also see, and most of the time we also see information related to roughness. How rough are those routes? Sometimes we just see the IRI value for the entire section, or IRI for the left lane and the right lane. Or sometimes if we concentrated in one section or in one lane, we may have one in the left wheel path and one in the right wheel path, and then we'll see an average. But what I'm trying to say is all this information related to section 001 would be at one single row that has every information you need for that section. Yes, and that's why we call it simple, because you would need everything, you would find everything from one single row. Going now to the other extreme of the type of database is the complex roadway database. So the complex roadway database, as it indicates, it has many tables. Each one will contain a different set of data, and therefore it's going to have different definitions of each section length. So this type of database typically must have a consistent location reference system, otherwise things are going to be really hard to track, and not everyone would be able to sufficiently use this type of database. This is here an illustrative example of the complex roadway database. As you could see, this is here pretty much a general table that doesn't have much of information, just give you the section numbers and the distress type and traffic and roughness, just as headings, if you will. And now you would see there will be one table just for inventory information, another table is going to be the stress table, another one for traffic, and the fourth one would be for roughness. So the very first one, the inventory table, you would see that the section is named 1001, which has to be hooked up with the first one here, which is D001, and the traffic T001, and the roughness is going to be R001. So instead of dealing with one single row of data for every section, now we will be dealing with 4 tables. And sometimes we have to go to this option simply because the database is expanding and you have so much data to include for every section, to an extent that you cannot just keep adding columns. You have to think of another alternative, which is a table for each data category. And that's what happens in the complex database system. So another aspect to think of and to consider, and you might be involved pretty much in this process, is the database development. So you may go to a small city or even overseas, and they are just starting to implement a PMS database, and they want to develop such database. So the development of a database really involves in 3 major steps. The very first one is you need to obtain a good system analysis, and then you need to design the system all the way to program it. So once you have those 3 steps in mind, then you will be able to develop a successful PMS database. So the very first bullet that you have to think of, which is the system analysis. What's the system analysis? It's simply you need to define a goal or an objectives to be achieved within the database system. Without having a clear goal of why you are doing that development of a PMS database, you will not be able to achieve anything afterwards. So first of all, you have to think of a system analysis, which is a major goal or a theme or few objectives that you are looking to achieve by developing such database. So while you're thinking of the system analysis as a payment engineer, you need to identify the cost which will require you to establish, operate, and maintain the system. So the very first thing that you need to think of is initial cost, and this is one of the big things that we have to keep in mind while we're starting up a new system. The initial cost would really require the majority of the hardware that you need to have to go to the field, measure the stresses, even in the office to buy software, to buy the hardware and software. Then you also have to think of the cost of operation. So once now you get the system up and running using the initial cost, you need to think of how much it's going to take me to keep it going, and that would be really including the application programs, the data collection, the data input, the data analysis, all the way to training the users, because it's not just going to be you. There will be several technicians and other engineers along the way that need to be trained to use the system. Also, I need to make sure that the system will, if we face any issues, we will debug any errors and will keep enhancing it in the future. Other related issues to system analysis, you also have to find out if you will be required to use specific hardware and software, or are you allowed to choose. For example, some existing agencies agreements might be in place and you are pretty much stuck with certain hardwares that they are already available, or certain programs that they have been using previously. While if you are in a brand new place and this new city or and country overseas that they are just starting the system, then you would have more freedom to pick and choose certain hardwares or softwares that you are comfortable with. Other related issues to the system analysis, you need also to keep in mind that you need to determine if the data to be stored and analyzed is exclusively for PMS, or it's going to be for other applications as well. So the amount of data that you will be collecting, such as traffic, the stresses, inventory, is it just going to be only used for PMS database, or can maintenance division use it? And can material design division use it? So we need to keep that in mind, because this is going to be affecting the availability of the data, the integrity of the data, and who should be able to interact and store and modify the data that you are selecting and storing. Another issue also, you need to identify the location of the users. Sometimes central offices is the typical way of dealing with PMS, while in a state like Texas we have so many districts. That's why when it comes to PMS for a big state, now we're going to have different districts, and every district has its own location, and every location has its own users, including technicians and engineers. This will significantly affect the hardware configuration, for example, as well as even the software. So we need to keep that in mind as well. Another related issue, we need to define the data flow from the time of collection all the way to the time it is produced as an output. It really affects the hardware and the application programs. So many times we think of sending the technician, go to the field, collect the data, but it takes so long to get it stored in the system. We need to think of this. How much time is gonna take? What's the flow? What's the standard way of doing it to collect the data and then transfer it to the system? This is gonna affect the hardware and the application programs, because sometimes you have to update the system, and therefore you cannot include and download the data at that time. So you need to keep in mind what time for the data to be uploaded, and reserve another time for updating the system, improving the hardware, or even obtain or do training for the people who are using the system. Another issue, based on my experience, you also have to determine if there will be any interfaces with other systems in your department. If so, then you have to document these interfaces and get the cooperations of other users. It's very similar to what I mentioned before, in a way that you need to understand if the data that you are measuring in the field related to PMS database, is it going to be used for other divisions or not. If it is, then you need to document this, and you need to let everyone know who is dealing with the data. It's not just the PMS group anymore. It might be used, and there will be a significant interface with the materials division, the maintenance divisions, and so on and so forth. Another related issue to system analysis, you have from the very beginning, you have to clearly define any analysis requirements to be used for the data. For example, the roughness data has to be converted to roughness index. In so many states, we have been using different types of roughness indices, but now there is the ASTM standards to measure the IRI, the International Roughness Index. So from the very beginning, you have to identify how to convert the data, the roughness data that you measure based on your local agency's procedure, to more or less a national number that everyone can understand within your system, within your county, within your district, and beyond. Another issue is you also have to define the cycle of events. That's a very important issue. That would include when the data is collected, when the data is analyzed, when the data is presented. Even you can put a date when the data will be transferred from paperwork to the software. This is very important. Some systems that they would define the cycle of events every year. Some other systems that they would have it 2 to 3 years, because the system is so big or the network is so long that they cannot have enough resources to do a payment survey every single year. So they would do it every other year, for example. So we need to define certain months of the year or in the 2 years period to send technicians and define, let's say, 4 to 6 months of data collection. Then these data in the next or in the following 6 months, they have to be entered into the system. Then this will be followed by another 6 months of data analysis, and lastly another 4 to 6 months to present the data. So this is your job as a payment management system engineer, to define that cycle of events and to make it going and working, and how can we repeat the cycle successfully. Now, part of the system design and documentation is the database structure. The structure, as we said, there are simple and complex. You as a payment management engineer, you have to decide whether the database is gonna be a simple or complex. In neither case, you must define the row that will be used in each table. That's very important for the organization of the data. Otherwise, again, things are gonna be complicated. In so many payment management systems, databases, we see a little bit of mix between simple and complex, and this make the efficiency of the system pretty low. So from the very beginning, you need to know, while you're analyzing your system and the amount of data and the network that you're dealing with, whether it would be beneficial to use a simple or complex database. So this is, I think I showed it to you before, but again, you need to think of, am I going to use this system, which is a simple roadway database, versus a complex roadway database. Again, there is no one better than the other. It's all about your judgment and the analysis and the amount of data available, the amount of sections that you're analyzing, and how big is the network, the payment network that you're dealing with. If it's a small network and the amount of data is small, then you may go for the simple roadway database. But once the system now starts to increase, the network is long, the amount of sections is huge, and even the data that you're selecting is a lot, then you may need to go to the complex roadway database, because simply the simple roadway database is not going to be sufficient and it's not going to be efficient to deal with. Part of the system design, here I'm just giving you some examples. For example, in the roughness table, each row will represent a 1 mile piece of road. In the condition table, each row will actually represent a section of the road which is homogeneous with respect to its conditions. So you see here, there's a difference between a roughness table and the condition table. Also, you have to think of the database elements. These are the data items that will be entered in each column, and how can we describe each row in the table as well. Something related to system design is the data integrity, and we talked about it before, but I just want to remind you again. How can you assess the data integrity is by asking yourself several questions. First one is, restrict the access to those data elements. Is it also develop utility programs to maintain the integrity? We need to give someone the responsibility to do it by hand, just to double check. You cannot just trust the program or the computer. All the time you have to do some on hand calculations and compare it to the system, just to double check that the data integrity is well maintained. Also, a very important point when it comes to design a system, payment management system, is having a good and accurate and up-to-date data dictionary. In so many big databases, including the LTPP database, we deal with a lot of columns, a lot of rows that we are defining several distresses, traffic by 1, 2 to 3 letters. Sometimes as you go to LTPP, to define fatigue is ALG, alligator cracking is ALG, and for the first time user you will not be able to understand what ALG means, or ALG underscore L, that means low severity alligator cracking, ALG underscore M, that's medium severity alligator cracking. So a data dictionary, this is an important document that will be used by the application programmers when they are developing the application programs, and it has to be available, it has to be updated by the time we include new columns of data. We have to design and we have to implement those new columns in the data dictionary. Another aspect to think of while we're designing and developing a database is to think of the data testing and acceptance criteria. This is a very important issue as well, that the testing procedure has to ensure that there is no bugs are still in the system, and that's why we typically do alpha testing. We come up with the software, we develop it, then we send it to some other engineers and technicians to use it, just to make sure that there is no problems with the system, and that's why we call alpha system. Detailed database design and documentation, this also has to be in mind. We have to always have user manuals, especially for new users that they are not familiar with the system. They cannot just start with the database that was developed years before them, assuming that they understand everything. We have to have such user manuals to implement the database and develop it in a very smooth and efficient way. Parts of the system design also is the application program design. The program itself, it has to have a major modules, if you will. The very first module would be having a module for the inputs. What are the inputs that we need to have from the field in terms of inventory data, traffic, distresses, roughness, to be used for the analysis. Then the program also have to have an output module. It has to have an analysis module all the way to testing and acceptance. So those are the 4 major points under the application program design. Also, as I was mentioned before, under the system development and field testing, we need to go through several testing among the engineers that they will be dealing with the developed database system before we finally conclude that this system is working 100% right. That's why the final system must go through the following. First of all, we have to have alpha testing. This alpha testing is simply an internal testing by a small group to identify any bugs. It's not even it's not going to be used from the entire group. It will be just used by very few amount of technicians and engineers to identify any bugs. Then we're going to go through the beta testing. So the beta testing, now we will be using outside users from across the spectrum of frequent and casual users who have realistic data. It's not just made up data, it's realistic data that will use the system and then have patience enough when bugs appear. We have to look for those outsiders users. Sometimes even outside the payment management system group, we may ask the maintenance division users, or we may ask the payment design users to come use it, use some realistic data, put it in, and then have again the patience to look for any bugs that it might appear. The major purpose for this beta testing is to ensure that all components and portions of the system perform their intended function in an actual operation situations. It's not just imaginary situation or some artificial numbers. It's true data, realistic data measured from the field, and we want to see that the system is fully functional. Then the third cycle will be the enhancement cycle. The enhancement cycle, we should not get caught in the continual enhancement loop. Otherwise, you will never get out of the development cycle. So the enhancement cycle, it's just going to be a continuous enhancement over the years. So alpha testing, beta testing, once we're done with the beta testing, we start to use the system, and now we start over the years to hear feedback of how to enhance the system and how can we include that enhancements in the future editions of the program. So the major thing to keep the system updated is we need to document the requested enhancements in a book. Then we have to meet to evaluate them periodically against objectives and scopes. Sometimes we will get some requests from other divisions that they are not really related to the payment management system, and then maybe we will not consider them in the current time, but we may have them in the future. And that's why the rule here is we need to document all those requests from the PMS division and other divisions, keep them, discuss them, and see if they fit our goals and objectives that were set from the very first day when we thought of developing the payment management system. So, and the very last stage after you develop the system, do alpha testing, beta testing, enhancement cycle, now is implementation and even evaluation. So it's not just about developing a system. Sometimes we have to implement it. We have to use it in our daily life. We have to convince others that it's usable and it's efficient and it's eventually is going to have some cost effectiveness over the years. And to do so, we have to think of having training programs. Invite people, invite technicians, invite engineers for a full day workshops or sometimes 2-day workshops, and train them on how to use the system. We also have to provide a good technical support. We also have to have a good communications among users. Users, again, among the PMS division as well as maintenance division and payment design division, they have to communicate together. And eventually we have to review the system periodically. Every 2 years to 5 years, we have to sit down, review all the feedback, and evaluate them and improve the system and keep improving the system as long as we go forward. With that, we finish chapter 5 that was related to PMS database development. Thank you so much.